Hello, hello all. Now I am going to explain how the three-phase induction motor produces rotating magnetic field. Okay, so if it is a three-phase, so we should know how to draw a three-phase waveform. So you can do like this. You can just draw. First you can draw the R phase, then draw the Y phase and draw the B phase. Okay. Now how are we going to prove that the three-phase induction motor produces rotating magnetic field? So we will be considering different instants, and in each instant we calculate the value of flux produced, and that the value of flux produced will be magnitude will be same 1 2 3 in every instant. The magnitude will be same, but the vectors of each instant will show you that the complete magnetic flux produced will be in rotating. So only two things we will be looking at it. At every instant we calculate the magnitude of flux, and also we see the direction of the vector. That's it. Okay. Now, so first let us see the position 1. And in this position, let us find out what is the flux produced by different phases. Okay, the three phase always have this point, like this is the maximum flux, positive direction, so that's why it is written plus phi m. Then the next, this one will be minus phi m. Now it at every instant when we see in every point, this point it R phase, other two phases will does not make the minus phi m, but in somewhere in between this point. So this point is called root 3 by 2 value. Okay, so this dotted line, this value is plus root 3 by 2, and this is a negative direction, so minus root 3 by 2. Okay, now at this instant look at it, the R phase. Now this R phase producing zero flux. At the same time, that is in this instant, the yellow phase is producing plus root 3 by 2, and then here the blue phase is producing minus root 3 by 2. Okay, so with these values we are going to see how are we going to calculate. Okay, now this is the position at position 1. So we have R phase, it was producing 0 value, then we have Y phase root 3 by 2 phi m value, and here minus root 3 by 2 phi m value. And let us draw the vector. Now we know here this is R vector, this is Y vector, and this is a B vector. R vector is producing 0 flux, and Y vector is producing plus root 3 by 2, and B is producing minus root 3 by 2. So this vector will not contribute anything. And now before finding the resultant, what we have to do? This one, this is in minus, so we have to make it plus. So bring this to direct opposite. So here this is the blue flux, this is the blue phase. Now we know that each phase is displaced by 120 degree. Now here it was 120 degree. When we draw this divided equally. So now this angle become 60 degree. Now we are going to find out the resultant between this vector and this vector. The magnitude are same, plus root 3 by 2 phi m plus root 3 by 2 phi m, and the angle is 60 degree. Now we can find out the resultant. Also, how to find out the resultant? We know the formula T q cos theta by 2. So where the q will be root 3 by 2 phi m and theta is 60 degree. Okay, so when we find out the magnitude is 1.55 m. Okay, 3 by 2 phi m, and the resultant vector says this direction. See this direction. So this is a magnitude. So I have drawn like this. So we can say like this. This is the direction of the vector. Now let us look at the position 2. Now already we have seen this section, position 2. In the position 2, see here. So here yellow is producing the 0 flux, red is producing the plus root 3 by 2, and blue is producing minus root 3 by 2. So this is the position 2. Now in position 2, same thing we have written, R plus root 3 by 2, Y 0 minus root 3 by 2. So now the vector, same vector, so R, Y, B value, the position will not change. This is R, this is Y, this is B. But now the Y is producing 0. Now B is again minus. So since B is minus, we are bringing it to other side, so it becomes minus root 3 by 2. Already R is having plus root 3 by 2. Now when we find out the resultant, both the vectors are same value, so the resultant there will not be any change, 1.5 m. The magnitude is same. But see the direction. The before the direction was different, and now what is the direction? This is the first position direction. This was the final direction. But here in second position, what direction we have? This is the direction. Okay, so from this direction, this is the first position, now this is the second direction. In the same manner, when we do the next one, the next will be here, same 1.5, and next will be here, next will be here, next will be here, next will be here, next will be here. So it keeps producing the same magnitude with the different directions. So hence we say that this produces a three-phase induction motor stator produces three-phase flux which is rotating in nature. This is what. Even now we can see the third position as well. Okay, now see the third position. In third position B is 0. Okay, B is 0, and now here it will be like this. So when we find out, because we can't draw exactly, it is plus root 3 by 2, and here the yellow will be minus root 3 by 2. Okay, so now let us calculate. We can do it on our own. See here, so here it will be R phase, and here it will be Y phase, here it will be B phase. Okay, and what was the condition? The B was producing 0, the R was producing plus root 3 by 2 phi m, and Y was minus root 3 by 2 phi m. And now since this is minus, we will take it in positive direction, so this will be plus root 3 by 2 phi m. And now this will be your resultant. See here, so first resultant was here, second resultant was here, and third resultant is here. So this is first position, second position, third position, so vice versa. So in every position we get always 1.5 phi m or 3 by 2 phi m. This is the flux value, magnitude is constant, and the vectors keeps rotating. Okay, so hence proved that the three-phase induction motor produces rotating magnetic field. Thank you. If you like this video, please share and subscribe. Thank you.